Very good morning and warm greetings to everyone. Today I am going to provide a video lecture on how to find the deflection using strain energy method. So in the previous videos we have seen about the deflection by using double integration method, McCullough's method, conjugate beam method and moment area method. So this is the fifth method to find the deflection and the slope in the case of beam. You know that strain energy stored is equal to the work done on the beam. For example, here I am going to take a very simple beam, which is simply supported beam. If the central point load W, which is acting at L by 2 from the left end of the support or L by 2 from the right end of the support. So, this is the problem and the solution to find the deflection and where the maximum deflection will occur. So the maximum deflection in the case of simply supported beam with the central point load is WLQ by 48 EI, where EI is the flexural rigidity of the beam in terms of kilonewton meter square or Newton into millimeter square, and where the strain energy stored in the case of beam is given by the equation capital U is equal to integral of the 0 to x, where 0 and x are the lower limit and upper limit, and into m square dx divided by 2ei, where m is the bending moment at the required point where you are going to find this deflection or the slope. So if the cross section is given and the x modulus of the material of the beam is given, you can able to work out the flexural rigidity of the beam in Newton millimeter square or kilonewton into meter square. So here the simply supported beam with the central point load, the reaction will be equally shared. So that is RA is equal to RB, that is equal to W by 2. That I already have shown in the case of a problem. Now you can see this is the simply supported beam, central point load L by 2, L by 2. This is W by 2, W by 2. So what about the bending moment at this section? At this section XX. So it is W by 2 into X, clockwise moment. So the moment at the section XX is M is equal to W by 2 into X, clockwise moment. Then you know that the strain energy stored is equal to integral of 0 to x into m square dx by 2 ei. You substitute the value of m. So here m is equal to W by 2 into x. So here, being a symmetrical loaded beam, I am taking the first half 0 to L by 2. So you can multiply by 2 to find the strain energy stored. So that's why you can see U is equal to 2 into integral 0 to x. Here mx is nothing but W by 2 into x to this power 2 into dx. Now we are going to integrate it and substituting the limits 0 to L by 2, right? So you are getting the corresponding value of strain energy stored is equal to W square into L divided by L cube divided by 96 EI. So that is the strain energy stored. You can see the strain energy stored is given here. So that is another equation, but you know that the work done on the material is equal to the strain energy stored. So what is the work done? That is gradual to maximal load is 1 by 2 into W into delta. Delta is the deflection at the required point here, delta C. That is equal to delta maximum, that is equal to Y max. So that is equal to, we are getting WLQ by 48 EI. So work done is equal to strain energy stored. Finally, you are getting the deflection will be maximum at the central point load under the load, that is equal to WLQ by 48 EI. So the deflection is a downward deflection. So the magnitude of deflection at the central point of simply supported beam is WL cube divided by 48 EI. L is the span of the beam and W is the applied load and E is the flexural rigidity of the beam. Finally, you will get the deflection in terms of meter, you convert into millimeter. So this is the way, right? So work done is equal to strain G stored. Get the strain G stored first, then apply the work done, then equate it, you will get the deflection at the required point. So therefore, Y max or delta max is equal to, or delta C at the central point, delta C is equal to WL by 48 EI. So this is the way you have to work out for this. In the case of strain energy method, this is the fifth method to find the slope and deflection of the beam. So we can see the numerical problem in the case of strain energy stored for either a simply supported beam or a cantilever beam or simply supported beam with a UDL of some UDL W is equal to small w is equal to 10 kilonewton per meter. So that we can see in the next video. Thank you very much for patient listening. God bless. வாழ்க வையகம் வாழ்க வளமுடன்.